Okay, so we are working on day 2 of the advent of code problems that we're going to be working on. So let's get our project started or set up. We're doing another C# console application. That's pretty simple. I want to use the same name scheme that I used before, so let's go ahead and pull up my advent of code. Oh, that's the wrong advent of code. Oh, I think I put it on the Z drive is what happened. There it is, advent of code. Okay, so the name scheme advent 2015 dot day. So that's what we're going to do. Advent 2015 dot day, and we're on O2. So that's going to be our program. We still want to use .NET 5.0. Boom, 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 boom. Alrighty. Excuse me. Excuse me. Okay. As before, I don't want to use static and everything. And after the conversation I had last time, I'm just going to quickly pull up the project from last time, which was advent.day1. And I'm just going to steal the Lambda expression that I had here, so I don't have to type it all back out. And then I'm also going to steal this file read to end, so that way I can remember what I'm doing with it. Mostly because that contains the path. So there's my Lambda. We want to get rid of this. And we're going to create a main function. Void main function. And then we're going to put our stream reader here, because that's what we're going to use. So as before, I'm also going to start by adding in my folder for data. I'm going to do a data text file, just like before. Clear that out. And then we also want a test data text file, which is the same thing. And we're also going to clear that one out. So, going back to our program. Okay, so we have our data and our test data files. Before I had done a notes text file as well, I'm just going to do notes here. So this is going to be our plan of attack for what we need to do. So let's look at what the project is. I briefed it over earlier, and I didn't think it was too terribly difficult, so it shouldn't require a whole lot of planning. So let's see. We're going to be measuring wrapping paper for Santa. Each box has a list of dimensions, length, width, and height. For each present, you only want to order the exact amount of wrapping paper that you need. Okay. Fortunately, every present is a box, which means that the left and right side have the same surface area, and the front and back side have the same surface area, and the top and bottom side have the exact same surface area, which means that if you get the top, left, and front surface areas and times them by 2, you have all of it, right? Which is what they're talking about here. 2 length width is your front and back, and then 2 width height is your top and bottom, and then 2 height length is your left and right. Okay, so we want to order that, but we also need to make sure that we're adding a little extra paper for each present. That area is of the smallest side, so whichever one of these is smallest, we're going to add additional 1 in, right? So let's, if length by width is the smallest surface area, you actually need 3 length widths areas versus 2. So for example, if you have a box that is 2 by 3 by 4, the 2 by 3 is 6, and the 3 by 4 is 12, and the 4 by 3 or the 4 by 2 is 8. So the smallest side is 2 by 6. So Your surface areas add up to 52, and you add in the smallest side again, which is 6, which brings you to a total of 58. Okay? So what we need to do here is, first off, we need to figure out the total area of each side. Figure out the smallest side. Add the smallest side to the total. And then move to next box. Because if I remember right, if I didn't read that far in, but I think that we have to measure all of the boxes total. So all of the numbers in the elves list are in feet. How many total square feet of wrapping paper should you try to order? So for this, like for our test data, we're going to do 2 by 3 by 4. And then the next line, we're going to do the, 1 by 1 by 10? Yeah, 1 by 1 by 10. Okay. So the next line is going to be the 1 by 1 by 10. So what we should do with our test data is we should make sure that we have a total of, that's going to be 43 plus 58. So what is that, 102? 101. 101. 53. 43, 58, 101. So we need to get a total of 101 when we run through this. Okay. So test data should result in 101. Let's go here. Test data should result in total area of 101. Okay. So far so good. All right, we have an idea of what we're going to do. We want to make sure that our stuff follows that. Now, the next thing we want to do is we need to get our puzzle input. Yeah, and these are line by line. So each box is separated by a new line, which is fine. That's good. That's what we want. Okay, so we're going to copy that. We're going to go ahead and place that in our data file. Okay, so we have all of our numbers. And this is why you want to do it as a program instead of doing it manually, is because there are 1,000 presents. And it's going to take you a lot less time to write this than it is to try to calculate 1,000 different surface areas and add them all up and account for human error. So that's why we're writing this program. Okay. So the first thing we want to do, as before, we're reading in the data. Okay, we're going to start with our test data, so make sure you're using your test data string. This should be pretty easy to do, so you should be at this point pretty quickly. I don't see anybody really struggling with this, so you should be able to get here pretty quickly. Now, what do we need to do? We need to set, because what data, this object here that we've done, okay, data, this data, what that is that is a compilation of all of the presents, all of them, as one string, okay? And if I actually were to run this and break here, let's break it here, and let's run this real quick. Okay, so data, if you look, it's one long string of the two boxes that I put in. And the two boxes that I put in are separated by /r/n. Okay, what the /r/n is the return new line. Okay, that's how you return new line in a string. So when you're typing out, like I could actually write console.write line. It might not work because it might escape, but I could say this is line 1, and then do /r/n. This is line 2. And so if I were to stop and rerun this, the console should put out 2 lines. This is line 1, this is line 2. So let's look at the console. See? So that /r/n is the same thing as new line. All right? And that's what's happening with our text file, is in here, each one of these, there's an invisible /r/n that causes it to be, a new, what happened? causes it to be a new line. Okay. So when it reads that, that's what it's seeing. So what we want to do is we want to separate that one long string of word or of numbers and stuff. We want to separate that into an individual object for each present. Okay. So what we're going to do is we're going to do a string array, which that's what this little double box is, or the box brackets. That tells it that it's an array. And what an array is a collection of those objects. All right. So a single string, like this string, is one string. An array of strings is multiple strings, each with their own index in this list. I'm going to use the word list loosely because it's not an actual true list, but it's a list. Okay. So it's a collection of objects that are all of the same type, and they're indexed. Okay, so we're gonna call this this array presents. Okay, and what that is going to be, so what we're going to assign to that is we're going to do data dot split. Okay, what split does? Split breaks up the data on whatever it is you're trying to tell it to break it up on. So in this case, we're going to break it up on /r/n. Okay, so everywhere that it's a new line, we want that to be a new present in the array. Okay, so I'm going to not do my test data real quick. I'm going to show you what this looks like with the real data. Okay, so our data is this one long line list of all these presents, and you can't see, it doesn't show the /r/ns here, but you'll see like all these are new presents, okay, and it's all one long list or one long line as a string. What we did is we broke it up into 1,000 strings that are in this presents object, and the one at position 0 is 4 by 23 by 21. The one at position 1 is 22 by 29 by 19. So each present now has its own separate index, and it's not all one long line of text. Okay, so that's step 1. We've broken them down. We have all of our presents separately. Okay, let's there we go. Let's make comments here. Break each present out of the string into an array. Okay, so now what we want to do, so we've got all of our individual presents. Okay, now what we want to do is we want to look at each present and get its height, its length, and its width. Okay, so what we're going to do is we're going to do a for each. So there's multiple ways you can loop through stuff. What we're looping through is we're going to loop through all of the presents. So there's 1,000 presents. We're going to loop through each of them. You can do a for loop like we talked about last time, where you do for the open condition, closed condition, iterate. Okay, for each does that, but it does all the logic for you for setting it up, and it makes sure you only go through each one time. Okay, so what we're going to do is we're going to do for each var present in presents. Okay, so what we're doing here is we're looking at every single item in presents. We're going to name that present for this iteration, and we're going to go through that until all of them have been gone through. All right, hopefully that's understandable. All right, so now what we want to do is we want to take that one present object. Let me break here and I'll show you where we're at so far. Okay. Okay, so we have our 1,000 presents. Okay, the one at position 0, the one at index 0 is 4 by 23 by 21. So the first present should be this 4 by 23 by 21, which it is. Okay, and then it'll do whatever's in this for each loop. It'll hit the end. Since there's still more objects left, it'll pull a new one. The new one should be the next one in the line of presents, which is the 22 by 29 by 19, which is at index 1, okay, which is what that present is. So it reassigned the new present to the same variable. All right, so far so good. Okay, so we're now iterating through and looking at each individual present. So let's do, what do we need to do for each individual present? Well, we need to get the height, the length, and the width, right? So we're going to do var dimensions. We don't want to do var. Let's do, it's going to be a string array, just like before. And it's going to be the dimensions equals present dot split. And we're splitting on x this time. Ugh, wrong button. Okay. So we're splitting these up on x. Now when it looks at the present, it splits them up and goes, okay, well, these are the 3 pieces that are separated by the x. Okay, so there's 3 pieces that were separated by the x. So present, you'll see 4x, 23x, 21, right? So we took the x's out and split them up on that. So now we have our 4, our 23, and our 21. Okay. Now, at this point, it's pretty easy to just multiply those together and go, okay, 4 by 23, 4 by 21, 23 by 21, etc. Okay, but we do want to find the smallest side, and the smallest side is always the smallest number times by the second smallest number, right? So, I wonder if we can do a sort. We should be able to do a dimensions dot or equals dimensions dot sort dot arrange dot. Can we do a split dot sort? Can't do it because it needs to be a list, I think. I think sorts have to be an actual list object. So let me try this. Let's do list of strings. I'll talk about list of strings in a second if this works. Or lists if this works. Because it should be better. Let's just do d equals dimensions dot sort dot to list I could probably do this. Let's do this. Can I not do a string dot? Hang on. There might be an easier way to do this. Let me just look real quick. It's not gonna work. There's not an easier way to do it that I can see real quick. So wait, can I do a to string dot to list? Nope. Okay. Let me put this back the way it was. It's a string array. Okay, I was trying to find a faster way to do this sort, but there's not really. What's a good way to? We could do another for each loop, but there's no point in that, really. I'm not using link, so I can't do the link statement easy. I think the fastest or the best way to do this is probably going to be to just compare the ending side area instead of trying to sort the smallest sides, which is frustrating. I know how to do it. I have a feeling part 2 is going to require us to have the smallest sides, not just the smallest dimensions, not the smallest sides. So I kind of want to do this, but I don't know for sure if that's part 2. So what I'm going to do is I'm going to do an if-else chain real quick. So if, well, let's assign these first. Okay, so we want ints. We're going to do int side 1 equals dimensions at index 0 dot. We actually want to do an int dot parse. Okay. All right, so what int dot parse does is it changes a string item to an integer item. Okay, but it won't work if there's a letter in there or something. Now we know there's not going to be any letters in there because the data is numbers, but we should actually do a try parse and do that so that way we don't actually blow it up if there is a letter in there. However, like I said, because we know there's not, we don't necessarily need to. So anyway, it takes this string item, which is going to be a number, but we're turning it into an actual number, which we can do math on. Okay. So side 1 is whatever number's at dimension 0. It should be. It's not side though; it's length. Anyway, int dot side or int side 2 equals int dot parse dimensions at index 1. So we're getting the next number out of this. And then int side 3 is int dot parse dimensions at index 2, which is the third number in the list or in the array. So, like I said, what this is you're taking those strings from this dimensions, okay, and you're turning them into integers and giving them a value, okay, or giving them to an integer item or variable. Now, there are a couple things we could do here. Like I said, we can if chain, or if else chain, which is what I'm going to do, but that's not going to work either. I don't want an if else chain. Let's just do. Yeah, screw it. Okay, so we're gonna do some more ints. We need to do a surface area for the front. So front equals, and this is going to be side 1 times by side 2. Okay. Then we need to do an int. This would be your left to right, so side equals side 2 times side 3. Okay, and then we need top and bottom, so int top equals side 1 times side 3. Because we have multiplied all the different sides together, because side 1 and side 3 are multiplied. Side 1 and side 2 are multiplied, and side 2 and side 3 are multiplied. Okay. Now we need to figure out which one of those is the smallest, and multiply that one by 3, and the others by 2. Okay. One thing that I almost forgot. So okay, so this is where you're going. What this is doing is we are getting total surface area. Okay. One thing that I forgot that we need to do is we need to actually, we need to get a total surface area integer for all of the presents, right? So we need an integer that handles the total surface area. And we're going to start that at 0. All right. Now, like I said, we're going to be adding to that every time. Which means that we also need to get a present surface area here. So int present area equals 0 as well. Okay, because we're going to set the present surface area and add that to our total surface area. Okay. Excuse me. So what we're going to do is we're going to do this if else chain that I was talking about. So if front is less than or equal to side and I did that one backwards. Give me 1 second. So if front is less than or equal to sides and front is less than or equal to top, that must be the smallest side, right? Oh, damn it. Right? It's got to be the smallest side. If the front is smaller than the side one and smaller than the top one, it's got to be the smallest size. So we're going to do total area equals total area, or not total area. It's not total area. I'm looking at present area. Sorry. Present area equals front. Let's do these in parentheses just so we can keep them together. Oops, parentheses. Because I want to make sure that we're doing these the right way. Times 3 I'll do present plus area plus front times 3. Sorry, my wife is talking to me. Now, if that's the smallest one, we know that the others are not the smallest ones. Okay, which means we need to add in present area equals present area plus sides times 2. And actually, because I'm going to do it this way for the instructional of it. but there's a cleaner way to write this. Okay, so if your front is your smallest, then you're timesing front by 3 and the others by 2. Okay, so let's copy this. We're just going to copy paste it. All right, but what if front is not your smallest? What if your side's your smallest? Okay, well, let's do sides. Okay, we need to switch that one to front. Okay, and this one to sides. Okay. And then this one will be 3. And this one will be 2. Excuse me. Okay. And you notice I added an else. Else just means like if this one is not true, then try this one. All right. If it wasn't, it would just say, is this one true? Is this one true? And it'll keep going. But this one, if this one is true, then it will not try this one. So what you're doing is you're preventing it from attempting multiple other goes. Okay, and you could just leave this one at else, because if it's not the front that's the smallest and it's not the sides that are the smallest, then it's got to be the top that's the smallest. But because I prefer redundancy, I'm going to do the same thing as before. Actually, I can just... Okay, and then this time you're going top. Okay, this is top. Toop. This is sides. And you're moving your 3 to the top instead of the 2. Okay. So far, we now have the total surface area of that present. Okay. When we get here, we should have the total present area of that present. And the first present we saw in the demo was going to be a total of 58. All right. So let's look at this. Let's see where we're at with the first one. Okay, so our present area for the first present is in fact 58. Okay, so what was the total surface area on the second one? The second one was 43. So let's double check and make sure that one's actually 43. All right, continue. The next one is 43. Okay, and that is for the present that is 1 by 1 by 10. All right. Okay. So far, so good. So we have our total surface areas of the 2 individual presents. But we don't have that adding into this total area yet. All right, so that's what we need to do next. We need to do, at the end of this, we need to do total area equals total area plus the present area. All right. And that should give us our total area for those presents. And that should be the end of this part. Let's just fix our lines here. So the total surface, or the total wrapping paper needed is total area. All right, this should work. Let's double check our idea here. So figured out the total area of each side, figured out the smallest side, added the smallest back into the total, which is the 3x. And then so let's run our test data then, because now we know our test data should result in a 101, and we've already iterated to the next box. So test data, total wrapping paper we need is 101. Cool. We're good there. Let's give our actual data a shot and see how close we are to the actual number. So what we need is, it looks like we need, what is that? Hang on. What is that? 1,598,415 square feet of wrapping paper for Santa's presents. Let's see if this is right. Congratulations, that is correct. So we did good. We calculated our smallest side. We tripled that one, and then the other 2 were doubled. Let's go to part 2. Oops, that's not what I wanted to do. Okay, Part 2, the elves are also running low on ribbon. Ribbon is all the same width, so you only have to worry about the length they need to order, which they would again like to be exact. The ribbon required to wrap a present is the shortest distance around its sides, or the smaller perimeter of any one face. Each present also requires a bow made of ribbon as well. Yeah. See, this is where I thought. This is what I thought. You would have to have the smallest sides. So, a present with the dimensions of 2 by 3 by 4 would require 10 feet of ribbon because it's 2 by the smallest side and 2 by the second smallest side. Okay. So let's go back here. This is where I wanted to do, instead of doing these sides here like this, I wanted to do, or instead of doing which face was the smallest, I wanted to do which side was the smallest. So we're going to redo our part 1 stuff a little bit. We should try to make sure it has the same result though. Okay, so I'm going to leave this here for now, and I'm going to work around it or work below it. Okay. So I'm going to do new ints. I'm going to do short side. Okay. I'm going to do int medium side and int long side. Okay. And I'm going to do something really similar to this. Is what I'm going to do. Okay. I hate to nest them, but I'm going to nest them. So if, well, we're going to leave these. I'm just going to use these in addition to. Okay. So if side, well, let's all set these to 0 first, because I don't want it to throw errors later. Okay. So if side 1 is less than or equal to side 2 and side 1 is less than or equal to side 3, short side is side 1. Okay. So what that does is it says, okay, if this side is smaller than this side and this side, this must be the shortest one. Okay. Now, we can't just stop there though. We need to go then and figure out the second shortest side, so we need to do another if statement. This is what I was talking about. I don't like to nest them like this, but we're okay to do it because it's just a small nest. So we've already checked side 1. Let's check side 2. Side 2, if side 2 is less than or equal to side 3, then that must be the second shortest side, which would be medium side, so side 2. Okay, and this is where I like the redundancies, because now I know, like, I can look back and go, okay, now what's going on? So we're going to do another else. If side, and this time it's going to be the other way around, side 3 is less than side 2, then the medium side must be side 3. Okay, which means that here the long side is side 3. Did my wife just try to call me? Oh no, she's texting me. Okay, sorry about that. And then vice versa. This one, the long side, is going to be side 2 instead. Okay, but that's only if side 1 is actually the shortest. If side 1 is not the shortest, it's got to be something else. So let's just, again, copy paste. This is really nice. Copy. So else, if, and we're just going to, so we already checked side 1. Let's check side 2. So we're just going to swap side 2 with side 1 for everything. Okay. And same thing here. Side 1. And then side 1. Okay. That's a pretty easy change off. So if side 2 is the shortest, but by being shorter than side 1 and side 3, the short side is now side 2, which means that then one of these has to be the medium. So if side 1 is less than or equal to side 3, that makes that the medium, or that one the medium. Okay. So now we have our if side 1 is the shortest, or if side 2 is the shortest. Now we just need to do if side 3 is the shortest. Else, if side, well, I can just copy paste. Like I said, I don't want to type all that out. Okay. And this time we're going to swap 2s with 3s. So 3, 3, 2, 3, 2, 2, 2, 2. Okay. So far, so good. Okay. So now we have our 3 different options for the shortest, and with each of those, you have your 2 different options for second, shortest, and longest. Okay. So now what we want to do is we can just take this little bit put it here at the end. I want to take this little bit with me. Oh, I need to take that with me too. Okay. So what we want to do, instead of doing this by multiplied by side stuff, what we're going to do, there's a trick in Visual Studio. If you control R, so you hit R twice, you can rename all versions of this. So instead of making this front, this is going to be small face. Okay. And small face is going to actually be small side. Oh, I need to move these. Oh, it's short side, not small side. Sorry. Short side times by medium side. Okay. And then our medium face is our medium side times by our, it doesn't really matter. We don't really care about the medium face. Times by our long side. And then our long face, or big face, is our, should technically be short by long. And then this would be your medium side by your long side. Because your 2 largest numbers should result in your largest surface area. Okay. So now I should have changed all our these. Medium face and big face. Okay. So this should result in the same thing at the end of the day. So we have our answer already. Let's just make sure this matches our answer. 1598415. 1598415. It's the same. So we ended up with the same thing, which is exactly what we wanted. What we did though is we refactored this to where we're calculating our side lengths. Okay. So our ribbon that we need. So now we need part 2 where we get ribbon. Okay. And I skipped over the notes again. That's fine. I don't use the notes as much. So to get the ribbon, what we need to do is we need to 2x our short side and 2x our medium side, not the face. Okay. So let's get a total ribbon here. We want an int ribbon length. Okay, so that's what we want, and so we're going to put that in our output as well. Console dot write line. Oops. The total length of ribbon needed is ribbon. What did I name it? Did I not name it ribbon something? Ribbon length. What? How is that not? Does not exist. What do you mean does not exist? It absolutely exists. Where's my error list? This is signed but never used. Oh, that's because I set it up in the wrong spot. It needs to exist up here by the total area. I just put it on the wrong one. Here we need to do an int. Let's change this one to total ribbon. And again, I did the control R, so I changed it down here as well at the same time. So that way it didn't, that way I don't end up with using the wrong variable. So this would be our ribbon length equals 0. Okay, so now we need to stay inside this for each loop, and you can check if you're in it by going to the front of this bracket. You see how it turns a little bit blue? Probably hard to see on the screen, but this one also turns a little bit blue, so we know that that's where the end of that for each loop is. So now what we want to do is we want to do our ribbon length equals 2 times our short side plus our long side, okay? And then we can take and add that to the total ribbon equals total ribbon plus ribbon length. And that should fix all of that. So let's use our test data real quick to just double check and make sure that we're right. So let's look back at what he gave us, or what they gave us for our example. Okay. That's only part of it. We need more. Sorry. I skimmed part of it. So we have our 10 feet of ribbon for the present, but to wrap the present, but we need to do for a bow. So how do we calculate the bow? So shortest distance around its side. Each present also requires a bow made out of ribbon as well. The feet of the ribbon required for the perfect bow is equal to the cubic feet of volume of the present. Don't ask how they tie the bow, though. They'll never tell. So that's huge. Like, that's a huge ass bow. So it looks like you times all 3 of the sides together to get the additional part for the bow. So the additional part in this case would be 24. So that comes out to a total of 34 feet. Let's go back to our program and add that part in. So our ribbon length is 2 plus that, or 2 times short side plus long side. But we also need to add in the rest of it. So ribbon length equals ribbon length plus short side times medium side times long side. Okay, so that should result in 24 feet of ribbon for the first present. Ribbon length 36. It should be 34. Short side 2, long side 4. 2, 4. Wait, what? Data? Test data? Sorry. 2, 3, 4. Ooh, we messed up something here. So our small face is not a small face. Short side. Short side is 2. Medium side is 3. Long side is 8. Oh, I did long side here. That should be medium side. Because our ribbon length is the 2 short ones. We don't want the long one, so medium side. Not. Okay, let's try that again. Make sure we get our right answer. Should be 34, I believe. Yes, 34. Okay. And the second one should be, what? What did they say the second one would be? The second one would be 10 and 4, so 14 total feet. So our second ribbon is 14. Which brings us to a total of like 48 because 34 and 14 is 48. Right? Okay. So, oops. Should be perfect. We should be good to go. So let's try it with our actual data now. Okay. Oops. Take out my breakpoint. So with the actual data, we need 1,598,415 square feet of wrapping paper, and we need 3,812,909 feet of ribbon. Let's see if that came out right. Congratulations, that is correct. All right, so we successfully completed day 2. All right, I'm going to end the YouTube video here. If you liked what you saw and if it helped you out a little bit, please like the video. If you have questions, comments, or anything you would like to add, please feel free to leave stuff in the comments. I know there are faster ways to iterate through this stuff. I chose ways that are easy for people who are learning. So, you know, if you have ways to speed it up, I'd love to see it, but I'm not going to adjust the video for anything more complex. Like I said, if you like what you see, please leave a comment and drop a like, follow, all of that. I will be back shortly with part 3.